Hello, this is the presentation of the Flyweight design pattern, also known as the cache design pattern, from Team 2. This pattern is a structural design pattern that is made to minimize the amount of RAM used when there are many objects. It does this by sharing common parts of the state between multiple objects, instead of keeping all the data in each separate object. This idea is somewhat similar to the separation of concerns design patterns that we've learned about this semester. However, in those designs, you separate the interface, logic, and storage. This works a bit differently, as you aren't always separating out logic and storage. You're taking out any pieces of an object that is often used to be shared across all of those objects, instead of being processed or stored individually. This is very important when building a program, as you don't want to make a seemingly simple program only be able to run on high-end machines due to poor efficiency. This can be useful in many scenarios. For example, in video games with many characters, you can share the common part of the state, such as the general body shape, movement, etc. Another example is in animation. If you need to create a scene with a forest, instead of rendering each tree individually, you can share the common features of the trees to make rendering much faster.
The example that we decided to lay out for our flyweight design pattern is a bullet in a multiplayer game. A poor design is if each bullet is created from a class with new characteristics for every new bullet, then as more and more bullets are created, the random access memory cost is greatly increased. In our example, if a bullet is 21 kilobytes of RAM memory, then bullets there will be 21 gigs of memory use. And this may seem extreme, but if this is the way for all the shrapnel, all bullets, every explosion and everything, this is easily achieved within a few minutes of gameplay. So our solution is to separate the common characteristics. The unique characteristics are created while only looking at the common characteristics. This way we can reduce the memory consumption, and the way we do this is we have intrinsic data, which is all the common data is its own class where anything that's changed or extrinsic state data is outside and can be changed by another program, but the intrinsic data cannot. And so with this design in place, at a million bullets, you're only going to use 32 megabytes of memory. And this is really important as more and more games are becoming online and necessary for computers to communicate seamlessly.
Now we'll talk about when you should use the flyweight design pattern. You should really only be using the flyweight design pattern under some specific conditions because it might not be necessary or even optimal. You should use it when there are a large amount of similar objects that are expensive to store, and when the memory footprint of the program is really high for the device that the program is running on. So you could see that being useful in certain games where they store things where it uses a high amount of memory and it stores things that are very similar. And objects, it should be used when there's a lot of objects that can be duplicated and shared between similar objects. So the way that the flyweight design pattern works, I put Mario and Luigi on the screen. It's because, they are very similar in many ways. They could be used as like the same character with slight edits for the fact that Mario's red, Luigi is taller, and you could save a lot of memory that way if you share those attributes. And it also is important that the object identity doesn't matter because these things are shared, so the identity could cause some issues. So here's some of the advantages and disadvantages of using the flyweight design pattern. The Flyweight design pattern improves performance by reducing the amount of objects in the program, and it also reduces RAM usage by sharing those intrinsic properties between the objects. But there are some disadvantages as well. There has to be a lot of shareable properties, like we've discussed, and there has to be no real memory constraint. I mean, if there is no memory constraint, it's going to be overkill. And it also makes the code complex and more difficult to implement overall.